They keep telling us it's a comet. Nothing to worry about. Just a comet. But there's a number sitting inside the James Webb data that has quietly rewritten every assumption we ever made about the space between the stars. At least 5 kilometers across. At least 33 billion tons. A body so massive it should not exist. So massive it breaks the statistics of the entire galaxy. And it's hurtling through our solar system right now. This is 3I/Atlas, the third interstellar object ever detected in human history. And James Webb hasn't just confirmed it's bigger than we thought. Webb has confirmed that everything we thought was wrong. Hidden inside that halo of gas is a mystery so deep, so old, so perfectly aligned with our world that astronomers are now asking a question no one wanted to ask. What exactly just passed through our neighborhood? And why was the biggest one of all of them? The one that got here first. Before we get to the number that broke the models, we need to understand what 3I/Atlas was supposed to be. On July 1st, 2025, a telescope in Chile, part of the NASA-funded Atlas survey, caught something moving across the sky the wrong way. The provisional naming came first, A11PL3Z, too fast for anything native to our solar system. Astronomers ran the numbers twice. The first answer was impossible. This object was not from here. It had entered the solar system from interstellar space, carrying a hyperbolic trajectory, the signature of a visitor, not a resident. Designated 3I/Atlas, it was only the third confirmed interstellar object ever found. The first was Oumuamua, a strange, silent sliver barely 400 meters long. No coma, no tail, no explanation. The second was Borisov, a textbook comet, ordinary and unremarkable, less than a kilometer across. And then there was this one. From the moment of discovery, 3I/Atlas refused to follow anyone's script. Only the second interstellar object ever observed with a coma, a halo of glowing gas. But it was bright, almost too bright, for its distance. Now, the world's most powerful telescope swung toward a single point of light millions of kilometers away, and every instrument that looked came back with the same unspoken message. Something is wrong with this object. But it took weeks before anyone understood exactly how wrong. Because here's the problem with asking how big is it when the object is a comet. A comet hides inside its own fog. The nucleus, the actual solid body, sits buried beneath a coma of gas and dust. Every telescope on Earth was photographing the fog, not the rock. And the first size estimates went insane. Activity models suggested the nucleus might be 10, 20, 30 kilometers across, a true monster. The Hubble Space Telescope looked closer and set an upper limit of about 5.5 kilometers, while allowing that the rock could be as small as a few hundred meters. The size of 3I/Atlas became the single most contested number in planetary science. The size mattered more than anyone let on, because the interstellar journey is not a casual walk. To cross the gulf between the stars, an object must survive radiation, cosmic ray bombardment, desiccation in a near-perfect vacuum, and time measured in millions of years. Small objects vaporize. Small objects get shredded. If 3I/Atlas was small, if it was merely Oumuamua's twin, then its glowing coma meant something entirely routine. But if it was big, if it was a genuine giant, then the physics of how it got here began to look impossible. Then came August 6, 2025, the day James Webb took its first look. Webb turned its near-infrared spectrograph on 3I/Atlas at 3.32 astronomical units from the sun. Still inbound. Still far out. Astronomers expected the standard cometary recipe, water sublimating in the distant sun's heat. Instead, the spectrograph returned something never recorded in any comet we know. The coma was dominated by carbon dioxide. Not water. Carbon dioxide. The ratio of carbon dioxide to water vapor. Roughly 8:1, among the highest ever measured in any comet, sitting 4.5 standard deviations above the trend every comet obeys. Of the gas pouring off this object, about 87% was carbon dioxide, 9% carbon monoxide, A scant 4% water. Think about what that means. Every comet in our solar system runs on water. Water is the engine, the heartbeat. This one runs on frozen dry ice, a chemistry forged near the carbon dioxide ice line of an alien star or battered by radiation across distances we cannot comprehend. Webb even caught water, ice, and exotic volatiles, carbon monoxide, OCS, sealed beneath the crust. It was chemically unlike any comet ever seen, and it was still months away from the sun. But the chemistry was only the beginning. While every observatory argued about the fog, Webb's data would soon deliver the number that changed everything. Here's where it stops being astronomy and starts being a reckoning. From May to September 2025, humanity tracked 3 I/Atlas with an intensity never before applied to a single passing object. For 1,000 precisely measured positions, 227 observatories around the globe. And from that mountain of data, a physics test was built, arguably the cleanest physics test ever performed on an interstellar visitor. It works like this. A comet's nucleus is a rocket. Every time the sun's heat turns ice into gas, and that gas erupts from the surface, momentum is conserved. The gas shoots out one way, and the nucleus recoils the other. Small bodies visibly deviate from their gravitational path. It's measurable, and it's called non-gravitational acceleration. If 3 I/Atlas were Oumuamua-sized, its glowing carbon dioxide jets would shove it off course like a leaf in a hurricane. Webb quantified the engine. The object was losing roughly 150 kilograms of gas every second, venting outward at around 440 meters per second, a plume's worth of material continuously. So where was the recoil? The data came back cold. The trajectory showed almost no deviation from a pure gravitational path. The upper limit on the object's non-gravitational acceleration, less than 15 meters per day squared. Nothing. The jets were roaring, and the object did not flinch. Then came the math nobody wanted to do. Feed in the mass loss, the venting velocity, the near-zero acceleration. The answer is brutal and unambiguous. To throw that much gas and barely move requires mass. Enormous mass. At least 33 billion tons. Which means the nucleus of 3 I/Atlas must be at least 5 kilometers across. More than 3 miles of solid, ice-rich material. Now compare that to everything we've ever seen from the interstellar deep, Oumuamua, a few hundred meters, Borisov, under a kilometer. 3 I/Atlas is orders of magnitude more massive than both of them combined by a factor of 1,000 or better. James Webb didn't just confirm a big comet. It confirmed the largest interstellar object ever observed in the history of humanity. And that's when the questions started, because a number that big doesn't just update your expectations. It shatters them. Avi Loeb had already done this math in a paper published days after discovery. Listen to the logic, because it is quietly devastating. Interstellar objects don't come from nowhere. They're born in planetary systems, then flung into the void by the chaos of planet formation, which means there's a census of ejected debris drifting between the stars, and in that census, small objects vastly outnumber large ones. Smaller rocks are easier to eject, easier to fling, easier to find. So ask yourself, what should we have seen before ever catching an object as big as 3 I/Atlas? Loeb calculated the answer. On the order of 100,000 Oumuamua's small, unremarkable rocks. We found 2, and on our 3rd successful detection in all of human history, we pulled the giant, the estimated frequency of an object this massive passing through our solar system. Less than once every 10,000 years. Once per 10,000 years. And it arrived in the exact decade humanity built the telescopes to see it. There are only 2 ways to read that, and both are unsettling. Either our models of interstellar debris are catastrophically wrong, or chance just dealt the most improbable observation in the history of astronomy. Massive objects are rare. This massive essentially should not happen. But size wasn't the only anomaly in the file, because once you know how big it is, you can't stop looking at how it moves. Here's the number that makes astronomers uncomfortable. Genuinely uncomfortable. Grown people with doctorates reaching for words like tantalizing and suggestive. 3. I/Atlas orbits the Sun on a trajectory inclined just 4.89 degrees relative to the orbital plane of the planets. Think about what that means. The solar system is a disk. The planets, the asteroids, every spacecraft we've ever launched, they nearly all live on that same flat plane. And this object, this visitor from another star, hurled across the galaxy by forces we cannot trace, threaded the needle. It arrived moving retrograde against the direction of the planets at a hyperbolic excess velocity of 58 kilometers per second, accelerating past 68 kilometers per second at its closest approach to the Sun. But it tracked the plane, almost exactly, within a 5-degree sliver of the most crowded highway in the solar system. Loeb put the question bluntly, and it's worth sitting with: why would the first massive object possess this alignment? Because alignment isn't random in the way comets are. Comets plunge in from every angle, a sphere of all directions, a body arriving from interstellar space at a specific speed at a specific angle onto the exact plane where the planets live. The geometry starts to look less like debris and more like a route. Its path carried it within a whisker of Mars, a minimum orbital intersection distance of just 0.018 astronomical units, under 3 million kilometers from the red planet. On October 3rd, 2025, it made its closest approach to Mars. Then on October 29th, it swung around the Sun at 1.36 astronomical units and accelerated back out past the planets toward the darkness it came from. The marble rolled down the exact center of the table and kept going. But the strangest detail wasn't in the orbit. It was in one single element, hiding among the gases of the coma. Using the Very Large Telescope in Chile, astronomers measured the object's spectrum and found something genuinely difficult to explain: nickel. Without iron. In every natural cosmic process, iron and nickel appear together in a nearly fixed cosmic ratio. They are forged together. They are destroyed together. Nickel, without iron, has essentially one known source in the material world: industrial manufacturing. Alloys produced through a specific chemical pathway, the carbonyl process, that humans invented to make steel. Loeb said it plainly. The detection of nickel without iron is only known to exist in industrially produced alloys. He built the cumulative case aloud: the mass, the alignment, the chemistry, the emissions. Individually, each anomaly has a small probability. Together, he argues, the chance this belongs to any class we know collapses to nearly nothing. The strangeness didn't stop there. In July and August, it erupted in a jet-like glow. Then, weeks before perihelion, it unfurled something entirely new: a conventional cometary tail captured by Gemini South. A tail on the object that runs on dry ice. Even NASA's Mars Reconnaissance Orbiter turned its most powerful camera on it, trying to see the rock behind the fog. And NASA itself stepped forward to draw the line. Tom Statler, NASA's lead scientist for small solar system bodies: it behaves like a comet. The evidence is overwhelmingly pointing to this object being a natural body. It's a comet, he said. Full stop. Except it's a comet that runs on dry ice, carries industrial chemistry in its gas, and followed the plane. Maybe it is a comet, in which case the only honest response is, we have never seen anything like it. And then Webb looked again, and the object added one final layer to the mystery, a layer 12 billion years deep. December 2025, 3 I/Atlas had swung past the Sun and was outbound, still glowing. Webb turned back to it, this time with its mid-infrared instrument on December 15th and 16th, and again on December 27th, collecting the first mid-infrared chemical fingerprint ever taken of an interstellar object. What it found rewrote the object's timeline. Methane, detected for the first time ever on an interstellar visitor. Not surface methane, methane sealed deep below, released only when the sun's heat punched through layers of ancient ice. And the methane-to-water ratio was anomalously high, with almost no analog in our own solar system. But the deeper revelation came from isotopes, the rarest fingerprint in chemistry. Webb measured the ratio of heavy hydrogen deuterium to ordinary water. In solar system comets, that ratio is one thing. In 3I/Atlas, it is around 30 times higher. 30. And carbon-13 was almost absent, the signature of an early metal-poor galaxy. Together, those isotopes tell a story that makes the hair on your neck stand up. This object did not form in a modern planetary system. It formed 10 to 12 billion years ago, at cosmic noon, the era of the most furious star formation in galactic history, inside a deeply cold, dense cloud around a star that is long since dead. It is twice as old as the Sun. The solar system did not exist when this object was born. It is by any measure the oldest comet ever found. An emissary, a fragment, a time capsule from before our own existence, still sealed, still intact, still carrying the chemistry of a place no human will ever visit. And it spent 12 billion years crossing the galaxy to arrive at our doorstep perfectly aligned in July 2025. The word coincidence has never had to carry so much weight. Here is the reality nobody says out loud. The door is closing. 3I/Atlas is outbound. It has blown past perihelion. It is receding into the dark, its gas production collapsing with every passing day. Webb watched the water shut off first, the coma dying as the sun's warmth fades. Within a handful of years, it will vanish from every telescope that can see it. It will never return. Its orbit is hyperbolic. It fell into our lives from infinity, and it will fall back out to infinity forever. We get exactly one look at this object. The only look, not in our lifetime, in the entire history of our species. That is why the greatest instruments ever built spent 2025 and 2026 burning precious time on a single speck of light. Hubble, Webb, SphereX, mapping organic molecules in the coma, the Very Large Telescope, and ALMA chasing isotopes, Gemini, the Mars Reconnaissance Orbiter. The most intensive campaign ever staged on an interstellar visitor, because there will never be a second chance. And here's the part that should keep you up at night. The next decade is about to change this entire conversation. The Vera Rubin Observatory is expected to begin catching interstellar objects at a rate of roughly one per year. ESA's Comet Interceptor is being prepared, waiting in space to chase the next one. In a decade, 3 visitors will become dozens, and those dozens will include more giants, meaning the question we are asking about 3I/Atlas, natural or not, was never really about one comet. It is the first real census of what is actually drifting between the stars. But stand with that thought for one more moment, because the timing does not get easier to dismiss. The largest interstellar object ever seen arrived in the exact decades when we built the eyes to see it. 12 billion years of cosmic history, and the big one showed up the century we were looking, almost as if it knew. We were finally paying attention. So, what did James Webb actually confirm? Not that 3I/Atlas is a spaceship. No one has proven that, and honest scientists will not pretend otherwise. What Webb confirmed is stranger and harder to swallow. It confirmed a body at least 5 kilometers across, 33 billion tons, a dry ice comet with less water than anything in our catalog, nickel without iron, methane sealed in its heart, a trajectory aligned to the plane of the planets, a chemical fingerprint from 12 billion years ago, twice the age of the sun itself. It confirmed that the largest interstellar object ever observed entered our solar system on a path no model predicted, at a scale no model allows, with a chemistry no model can reproduce. It confirmed the probability collapse less than once every 10,000 years. And it confirmed something else, quietly in the silence of the spectrograph, that the darkness between the stars is not empty. That debris from other worlds is everywhere around us, and most of it is small, harmless, and will never be seen. But some of it is big, big enough to survive the void, big enough to thread a solar system's plane, big enough that when it arrives, we notice. 3 Ice/Atlas is leaving. In a few years, it will be gone from our skies forever, back into the longest night there is, carrying secrets we only began to read. But it came here with a question, and that question does not leave with it. If the biggest object ever to cross our sky arrived by chance, what else is out there, following the same road? And if it didn't arrive by chance, then we have just had our first look at the mailman, and the universe has had its first look at us. The countdown, either way, has already begun.